We are going to go over day one of solving trig equations. So tonight I really just want you to watch the video, and then in class on Monday we're going to go through and solve 1 through 8. So make sure you bring your notebooks and everything in class on Monday and bring this completed. Thank you. So if we remember back, to solve the equation sine x equals cosine x, you want to look and you see the two equations that I have here. Here's the sine of x and here's the cosine of x. So you're trying to figure out where they're equal to each other between 0 and 360. And if you're looking at graphs, you can see that they're equal right here and then right here. And that corresponds to 45 and 225. If you needed to solve it out on paper, you can divide both sides by cosine of x and set it equal to sine x over cosine x equals 1, which then goes to the tangent of x equals 1, and then you know that tan of x is 1 when it's 45 or 225. But I wanted to make sure you see it visually with the graphs as well. So in order to solve these trig equations, you want to make sure that you have your formula sheet next to you, and you're going to substitute any trig identities or formulas that you need to. You're always going to try to set the equation equal to 0 and factor if you have the same angle. But remember, sometimes if you're solving for 2x, you have to make sure you go out another revolution and then divide everything by 2. When you first look at this equation, I want you to look at the angles. You have 2x here, but you have an x here. And because they're different angles, you have to make them the same angle. So you're going to go to cosine of 2x. Because it's already in sine, I'm going to use the formula of 1 minus 2 sine squared of x. And I'll set it equal to the 1 minus sine of x. And then according to my things, I want to make sure I bring everything to one side. So I'll add the sine of x. I'll subtract 1. That will get it equal to 0. These cross out, so you get negative 2 sine squared x plus the sine of x is equal to 0. And at that point, I'm going to see if I can factor it. I can pull out a sine of x, and I'll be left with negative 2 sine x plus 1 equals 0. I set both equal to 0. Negative 2 sine of x plus 1 equals 0. So here, the sine of x is going to be 1/2. So when does the sine of x equal 0? Well, it equals 0 when x is 0 and 180. And then where does the sine of x equal 1/2? It's positive, so you're going to be in quadrants 1 and quadrant 2. So x will be, it's a 30-degree reference angle, so you have 30 degrees, and in quadrant 2 it's 150. So your final answer would be 0 degrees, 30 degrees, 150, and 180. Okay? When I look at example 2, I have 3 cosine of 2x plus cosine x equals 2. And if I look at the note, I'm reminded that I can't factor out the cosine because the angles are different. I have a 2x and I have an x. So I really need to take this angle here and expand it. So I'm going to bring the 3. I don't want to use the cosine squared minus sine squared because then I'm going to have another function in there. So I'm going to use the cosine one, and that's going to be 2 cosine squared x minus 1 plus cosine x, and I'll bring the 2 over and set it equal to 0. So then I'm just going to multiply through. It's 6 cosine squared x minus 3 plus the cosine x minus 2 equals 0. And I'll keep going to simplify it. So it's 6 cosine squared x plus cosine x minus 5 equals 0. If I make that an easier problem for myself, I can think of it as 6a squared plus a minus 5. And that's going to factor to 6a and 5 and 1. And I want to get a positive a, so it'll look like that. I can bring that back here, and I get 6 cosine x minus 5 times cosine x plus 1 equals 0. I hope that you're able to see that I just tried to make it a simpler factoring problem for myself. Then I'm going to come back here, set both equal to 0. So I get 6 cosine x minus 5 equals 0, and I get cosine x plus 1 equals 0. So that would give me that the cosine of x is equal to 5, 6, and here I would get the cosine x equal to negative 1. We know when cosine's negative 1, x will be 180. I know that cosine for this one right here is positive, so it's going to be in quadrants 1 and 4. And the reference angle, if I use my calculator, is 34 degrees. So I'm going to say it's 34 degrees, and then in quadrant 4, it's 360 minus 34, so that's 326 degrees. So here are my answers. When you're looking at example 3, you're probably looking at this 2x thinking I need to expand that. But if I expanded it into the 2 sine x cosine x, I'm then going to have two different, like I'll have a sine and a cosine. I don't want to do that because if sine is the only one that you see, I can just go right ahead, divide by this 2. And now I have the sine of 2x is equal to 1/2. Well, I want you to think of this as like sine A equals 1/2. So 2x, the reference angle here, when is sine 1/2? It's 1/2 at 30 degrees in quadrants 1 and 2. So you're going to be 30 degrees, 150 degrees. And then you're going to go out another time because of the 2. So you just add 360 onto this. And you'll get 390 degrees, and then I add 360 onto that, and I have 510 degrees. Okay, and then your final step is to just go through and divide everything by 2. So now I have that x is 15 degrees, I'll have 75 degrees, 195, and 255. Okay? So you should be all set at that point. This problem, I can't use I can't do it just like problem 3 because of I have this angle and I have that angle. So I need it to make sure it's all cosine of theta. So I'm going to expand this out, and that's going to be 2 cosine squared theta minus 1. I'll move that cosine to the other side, so it's minus cosine theta, and that equals 0. I'm just going to put it in an order that you can see it better. So it's 2 cosine squared theta minus cosine theta minus 1 equals 0. If I want to make it a simpler problem, I can come over here and say it's 2a squared minus a minus 1. And that will factor into, you have 2a and a, you're going to have 1 and 1. You want to get a negative a, so you have to have this be your negative 2a, plus a would give you the negative a. So coming back over here, I'll have 2 cosine theta plus 1 times cosine theta minus 1 is equal to 0. I'll set both of them equal to 0, so this becomes cosine theta equals negative 1/2, and this becomes cosine theta equals 1. So the reference angle for this is 60. It's negative, so it's in quadrants 2 and 3. So your theta is going to be 120. And then in quadrant 3, it's going to be 240. So that will take care of that one. And then here, where is cosine equal to 1? Well, that happens when theta is 0 degrees. You could also, I know you think it's 360, but if you go back and look up here, it's just less than 360. It's not less than or equal to, so you don't include the 360. So this problem looks complicated. You might think because of this you need to do angle addition. You don't. You don't need to do that. What we're going to do is I'm going to make it like an easier problem for myself. I'm going to take this and come over here and say, okay, a is x plus 25. So now I have 2 sine of a equals rad 3. So the sine of a is rad 3 over 2. Well, I know that the reference angle for this is going to be 60 degrees, and it's in quadrants 1 and 2, okay? Because sine's positive. So A will equal 60 degrees, and then it's also going to equal 120. I'll go back to my A, and I'll say, okay, well, x plus 25 equals 60 degrees, and x plus 25 equals 120 degrees. So I just subtract the 25. So here, x is going to be 35 degrees. Here, if I subtract the 25, I'm going to get x to be 95 degrees. And that's how you do that pretty simply. Do you have to show me, do you have to show this step? You could have left it as x plus 25 and then come here and just say x plus 25 equals the 60 and the 120. It's fine, but I think visually it might be helpful to do this substitution.